everyone for joining to our first of the weekly advanced webinar series. What we're trying to do here is really just give you guys some insight into some of the more complex technical challenges that you face while working with our products. So today we wanted to focus a little bit on voice evacuation programming, how we configure, set up a system, and the actual programming behind it. And what we'll do is leave you guys with a little template for the programming here. So if you're doing any voice evac jobs coming up soon, then you can just use that template to get you kickstarted on your programming and hopefully get you in and out of the job a little faster. So with that being said, I'm going to turn it over to Greg now, who's going to take us through the technical specifics of voice evac programming.
Well, great. Thank you, Chris. I do appreciate it. And all of you, thank you for joining us. We are going to talk about the voice evacuation programming. Well, I'm going to begin this item here and talk about our voice evacuation. There's a couple of different items that we can do with the system. We have a V-series panel, command center panel, which you see here, along with what's known as the VBM voice box with microphone. And then we also have an item that's called the VB, which is voice box, no microphone. All of these items have inside of them an item called the AV Amp audio amplifier. So the 80-watt amplifier, it has two independent 25-volt RMS 40-watt amplifiers. It can be wired either Class A or Class B, and it uses a common message chip. The programming can be set up as a one-for-one backup of the amplifier, and then built on board, as you can see by the arrow, there's an integral jumper that's built in so that you can test the failure of an amplifier and see it switch over. Now, there's two versions of firmware built into all of the amplifiers. There's a hardwired version and the P-Bus 485 version. Now, you can add multiple amplifiers into systems, whether it be a fire panel or a pen unit. Again, it's the Amp 80s or the VBs with or without the boost. Built on board the unit, there's a set of fail-safe trouble contacts. And there's also, we monitor the microphone for its input placement and the wiring attached to it. We can program in our amplifiers either up to 2 messages for the hardwired unit or up to 16 messages in each amplifier in the intelligent P-Bus controlled amplifier. Now, the amplifier circuit board is mounted onto a metal plate, and that metal plate is used to dissipate the heat when the amplifier is activating. So it must remain on that unit. And it does require its own dedicated power supply and charger. It needs, of course, will need a set of batteries. Now we program this amplifier using the AX config tool. And we'll see that in a little while, and I'll show you how to put that together. Now there's a couple things about the amplifier that we need to review. It has to do with addressing and the onboard LEDs. So when we look at the onboard LEDs, there's 6 of them. There's the TX, the HB, the AMP1 and AMP2, 40V, and the USB. Let me explain what those are. If you were going to hook up your laptop and send some data into the amplifier, what would happen is you would get that TX light flashing as you're transmitting data from your fire panel programmer into the amplifier. Heartbeat light, well, that typically is pulsing on and off, indicating that the unit is powered and the processor is working. Then you have the A1 and the A2 amplifier LEDs. A1 is circuit number 1 and A2 is circuit number 2. Normally, they would be on steady if the amplifier is active, or they would flash if the amplifier is in trouble or in short circuit. And incidentally, there's an item, as we call it, the 40V LED. When the 40V is a test function that the amplifier does, and what happens when the 40V kicks on is that the amplifier A1 and A2 also turn on, and that's when the amplifier is testing itself. Now, we talked about earlier is that the amplifier can be set up as 2 40-watt taps, or it can be set up as an amplifier with backup. And in this case, this is how the unit determines whether the amplifier has failed and will switch over via a set of onboard relays. And the last item is the USB LED. Now, when you plug in your laptop to the amplifier to transmit across the message set, you will see that that 40V light does in fact kick on. Now you also have on the amplifier and this is in the intelligent version, there is a switch pack that has 4 dip switches on it. This is how we address the individual amplifiers. Every fire panel or pen, and a pen is a peripheral expansion network node, think of it as a fire panel, but it doesn't have anything like NAC circuits or SLC circuits. It just has the P-bus, and it's a networkable item. So we can put these amplifiers in the VB unit out in the field. And so the dip switches are valued at 1, 2, 4, and 8. If you added up those numbers, you would see that, oh, that equals 15. You wouldn't normally have an answer, address of 0 in, say, a pull station or a smoke detector, but in fire alarm cards, motherboard talking to its daughter cards, we use the address 0. So we have 0 plus 15, and that gives us our 16 cards. So really quick, I want to talk to you about the hardwired, just so that you understand the difference between hardwired audio and the software-driven audio. So on the hardwired audio, we can have up to 2 messages. Okay. Now there are 3 onboard relays that would trigger those individual messages. Input number 1 triggers message number 1. Input 2 triggers message number 2. And then input 3 is actually not a message, but it's a regeneration of an input signal. We take a 25 volt RMS signal and then regenerate it at 40 watts coming out each of the taps. So we also, again, we supervise the microphone for placement. And as you can see there, that indicates where our input 1, input 2, and input 3 are located. Now, as far as the messages themselves and what the prioritization is that the highest level is if you have a microphone attached. When you key the microphone, that is the highest level of input, followed by the boost mode. So in the boost mode, that's where, the input 3, if we take a signal coming in and we regenerate it back out again. And then inputs 1 and input 2. Input 1 is higher, and that's typically your fire alarm message. Might be just a 520 hertz tone, or it might include a voice message along with it, but that's what that is. Message number 2, or input 2, that's typically used for something like an all clear message after the fire has occurred. That is, in fact, the lowest message. Now, the amplifier is supervised, again, via the Form C onboard contacts, and you would put that to a monitor point somewhere on the system, whether it's an input point on the fire panel or a monitor module out in the field. So let's compare that unit to what's known as the 485 unit. That is the intelligent amplifier. It looks exactly the same. There's no difference. The only thing we do differently is that we invoke the other version of firmware that does reside in it. So there are 3 types of P-bus amplifiers. Okay, there's 3 types. We set those up as the first one is a microphone bus amplifier. So in a system, if we have a microphone on these intelligent units, we dedicate it as a microphone bus amplifier, and it does nothing more than provide your analog voice in and out of each of the area amplifiers. We also have what's known as a remote microphone bus amplifier. And what this does is it gives us the ability to have another location. Maybe it's a remote command center. Maybe it's just another side of the building, something to that nature. But you can have maybe even an LOC, local operating console, same idea. So then we also have, as the third item, we call it the area amplifier. It's a floor or a zone amplifier. And you can have multiples of these in the building. You can have as many as 16 per panel or pen unit. You can have multiples in an area. You don't just have to have one. You could have several amplifiers in an area. Now, in each of those amplifiers, you can put up to 16 different messages in them. And if you were to go off the normal, you can customize the prioritization. But typically, message 1 is the highest message, and so on and so forth, down to message number 16. One of the things that we do with this type of an amplifier is that we use the perfect sync control across the P-bus network as well as the RS-485 network from panel to panel. And in doing so, what we do is we synchronize the timing of all of the amplifiers, whether it's on a pen or on a panel and across the network. So if we use a common message set for all of our amplifiers, they will in fact sound as if they are making a noise as a bulk system, one location starting the noise. They all sound like they're sounding together. And they do that via that perfect sync control. Now again, we supervise the mic for the input. If somebody happens to disconnect it or hold the microphone down more than 180 seconds, we'll get a trouble on the panel. All you have to do to reset that is release the microphone and then rekey it, and it starts over again. What we didn't want anybody to do was to inadvertently wrap a piece of tape around it and key the microphone and then go from there, because we said the microphone is the highest priority, and that would prevent any audio signal from coming out. Okay. Next item we have is we have a supervised power supply charger input. Now before, with the hardwired unit, we said we had to have a monitor point to monitor that. What has changed on the amplifier was that 6-pin connector, that input 1. We used to trigger message number 1 with it. That now becomes a monitor point. We don't need a separate monitor to monitor the power supply that's going to give the power to the amplifier. Now we use the treble contacts and plug them in there, and then that amplifier supervises its power supply. In addition to that, as we said earlier, there are dip switches for addressing these units. And again, we can have up to 16 per panel or pan. You can have multiple pans or panels. You can have up to 200 nodes on a Class A style network. And then finally, the amplifier is supervised and controlled by the P-bus. And what I mean by the P-bus is that the main motherboard or the pen unit is what's telling this unit what to do, and in addition is monitoring it for any of its off-normal conditions. Now, there are some tools that are required to program the amplifier. The first item is the AX config tool. Again, you cannot program this in the faceplate of the fire panel. You do need to use the AX config tool. And the other item that you need will be the AX amp tool. Again, you can't program this anyplace else other than using these tools. Okay, so while we have these in the AX config tool, this is where we add the amplifiers to a site-specific program. And we'll do that shortly. Once we add the amplifiers to the system, you choose whether it's going to be a mic bus amplifier, a remote mic bus amplifier, or an amplifier for an area. And once you choose it to be an area, you tell it what area it's going to be assigned to. It's also where you would add a switch card to instruct the amplifiers what they're going to do. You have the amplifier in the system, and then you'll have a switch card. In the switch card, you push buttons on it to say, page this area or something to that nature. You will also write programs to instruct the amplifiers which of the 16 messages that it's going to play. And we'll walk through that as well. Now, as far as the amplifier tool, this is where you set up the amplifier to be intelligently controlled versus hardwired controlled. And I'll show you that. And we also set up in the amplifier whether it's going to have a 1-for-1 backup. We said it has 2 taps at 40 watts. We choose whether we're going to use both taps with no backup, or we're going to use only one of the 2 taps and leave the other one to back up that particular unit. This is also where you load specific messages into the amplifier. You create what you want for a signal in the building, and then you load those into the system. And finally, what you can also do is that you can import a specific type of message. We have areas where they have different language speaking folks, where maybe it's a combination of an English and a Spanish, or English and Russian, whatever it needs to be. You can create your own messages. There's a tool out on the web, and it's called Audacity. There are some specifics that you need to set the message up, but that's where you can go and create it. So we'll take a couple of moments here. Let me show you. This is a screenshot of the AX series configuration software. So a couple of things that we have in here is we're going to select the P-bus. We're going to add some devices there. We're also going to click on the patterns. And the patterns is how we determine when something happens. We're going to ask, in the pattern is to select the specific message in an amplifier to play. And then we also have what's known as the output groups. And in the output groups, this is how we determine how the system is going to work, whether it's going to be a general alarm activation or it's going to be a selective signaling. What I mean by selective signaling is when the fire alarm goes off on a floor, it'll activate on the floor of the incident, the one below it, and the one above it. So really quick here, our basic tasks that we're going to do, and I'll show you how to do this. And I'm going to kind of pop this thing back and forth here because I want to show you both of these items at the same time.